So, yeah, as you heard, my name is Brian. I will do something on state management in Angular using RxJs. Yeah, so the first thing that you're going to look at is what problem do we have that state management comes in to solve. So normally, let's say you're getting some data from an API. Normally, we use a service in Angular. But as the project grows, you realize you'll have so many services in your project. So if you have 100 entities, that means that you most likely have 100 services, because every entity has a service or something of that sort in terms of design. Now we need to come up with a single source of truth in our application, so that we do not have all these many states that are not manageable for a large project in that manner. So that is the gap that state management comes in to fill. And one big advantage that comes in with state management is the fact that data flows in one direction, and therefore you don't have so many data inconsistencies in terms of your management of your data. Now, one way to achieve this is by using RxJs, and we have other tools, NGRX, which you can use. But for our presentation, we'll mainly focus on RxJS. Now, in that RxJS, of course, Rx means reactive, and the JS is definitely JavaScript. So therefore, RxJS is reactive extension for JavaScript. So the word reactive is very key, and we look at it in the next slides to just discover what being reactive really means in a software engineering perspective. But one thing to note is that RxJS, they define themselves as a library for composing asynchronous, yet another keyword that we need to look at, and event-based programs by using observable sequences. So asynchronous basically means it's non-blocking. For synchronous, it's blocking in the sense that you make a request and you wait for the response to come back. In asynchronous, you make a request and proceed to do other things, and when the response comes, you subscribe to it, and you subscribe to an event listener that will notify you when the response comes. So you can just proceed to do whatever you want to do, and therefore there is no locking of threads, or rather blocking of threads, not locking. Now, RxJS, of course, all this state management stuff works on top of a pattern. Welcome to the world of design patterns. There's a pattern called the observer pattern. And of course, because of the so many listeners, there's also the iterator pattern. But we would like to focus more on the observer pattern because that forms the basis of what state management is ideally. Now, as we had said, RxJS, the Rx stands for reactive. So let's look at what a reactive application is. So according to the reactive manifesto, a reactive application is four things. One, it's message driven. Two, it's elastic. Three, it's resilient. And four, it's responsive. Now, what do we mean by message driven? By message driven, we mean it's data. It's more of the data, not anything else that drives these applications. So it uses asynchronous communication such that the design of sender and recipient are not affected by means of how you propagate the message. As long as the message is there, we don't care so much about the finer details. Secondly, it's elastic. So it means it reacts to load. You can scale up, you can scale down based on traffic, based on resource usage, and all those things. Third, it's resilient. So they react to failure. You know, failure is inevitable. But how you react from that failure by either restarting or reprovisioning resources back is what makes you reactive. And finally, it's responsive. Applications are powered by users, so they need to react to users, and that means that you detect problems quickly and deal with them effectively. So that is just to give a glimpse of what really we mean when we say that RxJS is a reactive extension for JavaScript. Now, the main focus for what you are doing will be the first point, which is message driven. the asynchronous communication bit is very important, because that means that you don't block, and that gives you a big advantage in terms of performance of your application. Now let's move forward. Remember, we said that most of these state management things are definitely built on top of the observer design pattern. So the observer design pattern is belongs to one of the 4 categories of design patterns, which is the behavioral design pattern. Now, in the observer, you have 3 actors. You have the subject, which is an object having methods to attach and detach observers. So observers are subscribed to listen to a certain subject. So this subject will definitely have logic to attach these observers to a client object. If you talk about a client, I'm quite sure when you've written your Angular code, there's a point where you do .subscribe. You're ideally subscribing to an observable. And in that case, you subscribe to that subject. And in that case, the service is the observer, and then the client is your component, which is subscribing to a certain observer. So that is the observer design pattern, and it forms the basis of everything. State management, RxJS is built on top of this, or rather, really implements a lot of things that are discussed in this observer design pattern. Fast forward, now we look at the concept. This is not very, it doesn't limit us, but you can just take a quick peek into the RxJS concept, very keywords that are used in this. So we have an observable. So an observable represents the idea of future values or events that can be invoked. That's what an observable is. We have an observer. So this is a collection. Okay, an observer would be something like, from this example, an observer is just an observer from the context we discussed from the observer design pattern, which is someone who's watching on an observable. Then a subscription is usually the execution of an observable. That's why we always do .subscribe. In that case, you're just creating a subscription, which is the actual execution of that observable that we created. Then RxJS also has a few operators, which are pure functions. And pure function means you receive some input, and you'll always have the same output for a given input. So that's what a pure function is. F of x is equals to y. Given x, y will always be the output. That's what a pure function is. Then the subject is the event emitter. So for instance, the subject should be an API call, and that is what you would emit eventually. Then schedulers, they're just dispatchers to control concurrency. E.g. the set timeout function, you must have seen it somewhere when you're writing your Angular code. So that forms the basis for RxJS. And we can just move real quick to the next thing. Now we look at state management in RxJS now. So we look at an example of state management in RxJS, and we look to guide us. I think it's always good to follow patterns. And one of the patterns that has come up for this kind of things is a pattern called the flux pattern. Now, most likely, the guys who've done React, you know React Redux, which is a very powerful state management tool for React. And React is actually managed by Facebook. So Facebook designed a pattern called the flux pattern, which they used to design the Redux. So our example would be based off the flux pattern. Now, what does the flux pattern entail? So as we said, it was designed by Facebook, and it splits applications into 4 parts. The first part is the store. The second part is the dispatcher. The third part is the view. And the last part are what we call the actions, or the action creators. We look at each of them so that we understand how this flux pattern is built, so that when you get into our example, we can easily flow around with it. Now, we'll start with the store. the store manages the state. So this could be domain or UI state, whatever kind of state. But store and state are not the same thing. Store is the actual data value, while the store is a behavior that manages state through methods. So a store manages multiple objects and is the single source of truth in regards to those specific objects. That's what you believe in. That's why you go to the store, get whatever you want to get. Remember we said data flows in a unidirectional manner. So there are no setter methods in the store. And for you to change state, you need to go through someone called the dispatcher. You need to perform an action to the dispatcher so that you do not have data inconsistencies. Because if you have a setter methods that goes directly to the store, you have a big problem because you don't have, you need to have only one point of entry in terms of making changes to the store, and that is the dispatcher. The dispatcher will have all the logic to do whatever it needs to do. So the store listens for all actions and decides on which of them to act. You can think of it as switch logic, as you will see in our example. So you just have a switch and so many cases. Case 1, case 2, case 3, you perform this piece of logic based on the input that is coming in. And once the store has made the state change, it emits a state change event. So you get any state change, you need to inform the people who have subscribed to listen to you. So you need to inform the guys who have subscribed, or rather anyone who has subscribed to listen on any state change. So that is it for the store. We'll move to the next thing, which is the dispatcher. So remember, we said we do not do updates to the store on our own. We have to go through the dispatcher. Now, what the dispatcher is, it's a single object that broadcasts actions or events to all registered stores. So every state change must go through the dispatcher. Stores need to register for events when the application starts. So a store needs to register to a dispatcher, or rather say, I want to listen to events through you when the application is starting. So when an action comes in, it will pass that action to all the registered stores. So if an action comes in through the dispatcher, it forwards to the stores so that the state can change in that manner. Now, the third part, remember we've already discussed the store, the dispatcher. We're discussing the components of the Flux pattern, store, dispatcher, then the third one before the last one, which is the views. So this could be user interface components that are responsible for rendering whatever you see. Now you have state. Now let's say you have in our example, we'll be looking at an example where we have friends. So the view is that component. You can think of it as a component that displays the actual data from the state, or rather the state. Yeah. So they also listen for store changes and then they render. Actions is a plain object that contains all information necessary to do that action. And actions have a type property that identifies the action type. So these are just, you can think of it as an enumeration, because this is what will be used in our switch block to determine what action to take. And then actions should be immutable, as they are carried around in the application. They should never change, immutable. Yeah. So we will look at a hands-on session just to get a good idea of what we are talking about. And I have done some work here. So the idea is to have a friend's applications with an example where we will see the store, we'll see the actions, we'll see the dispatcher, and we'll see the views. So I think we can proceed to the session. If there are no any questions, we can proceed to the hands-on session. Okay. So this is just a typical Angular application. I might have broken some rules because of it's just for demo purposes. But as you can see, there's a folder here called store that has two things. It has the action, and it has another file called index. And then you have two components: friend create and friend listing. So those are the two components that we have. One is for creating a friend, and the other one is for listing the friends that we have. Then we have another interface here, which is the friend interface. So this is what we are using to represent a friend. We have a friend as an ID, a name, an email, and a phone number. Now, the most important bit is this bit where you have the action. So remember from our discussion that we've had here, an action was a plain object that contains all information necessary to do that action. So we have 3 actions. We can either create a friend, delete a friend, or get all friends. So those are the actions that we have at this moment. But remember, we also have something called the dispatcher. Now, this action is very key when you come to creating your dispatcher. This is our dispatcher, by the way. And we'll just come up here. So we'll start with the initial state. So we have friends, which is an array of anything. Then we have these states. This is an interface. Then the state, which is the initial state of type initial state. We have friends inside. Then we have an event. So an event, as we said, has a type here, as you can see. As a type, we have type here, and the payload that comes, or the data that we will need to use for that event. Then we have a store, and something called a subject. So our store is a subject, and a subject is an RxJs class. It's a class in the RxJs package. So we have a store here, and we initialize it with the initial state. Now, after that, we have a dispatcher. Remember, we said a dispatcher is what will broadcast actions to all registered stores. Since we have a few actions that you want to do, we start by switching. So remember, we've always talked about a switch block, and we are switching on the data, the event which is coming in, and we are switching on the type. So remember, one of the types that we have is create friend, delete friend, get friends. Now, on this event dispatcher, we need to do a switch block so that we can resolve the action and do whatever we need to do. If the action is get friends, all we do is get the state as it is. If the action is create friend, we create a new, there's a payload that is coming in. Definitely, if you're creating a friend, there's data that is coming in, the friend data that is coming in. So that data, we just pick it and append it to the state. So the state has friends, so you just append it. We're doing a list match here, an array match, an array filling. So we're just doing concatenation of some sort, and then we save that state. We save that to the store. If the action is delete friend, you get all the friends, and then you filter by a certain criteria. I am using an email here to do that. So you and then you update the state with the updated friends. So I'm just filtering from the list what I need, or rather remove from the list what I don't need, and then update the state with a new updated friends, which is the new list that is coming in. So that is the idea. So there's an action. All these 3 are actions in the dispatcher. Then this is the dispatcher. Then you have a store, which is the subject, which is an RxJs thing. And I think that explains the whole thing from a Flux pattern perspective in terms of the few elements that we had discussed. You've seen the store. We've created the store here, the subject. We've also seen the dispatcher. The dispatcher is here. The views are definitely our components. And then the actions, we have them here, the case statements. Now, what exactly now do we get from that? So here is our thing in action. So I have a new friend called Taiwo. Then we have an email, taiwo@gmail.com. Then we have a phone number, which is that. For instance, that's it. So when you click the add friend, we will come, but where we are calling this, I'll just show you in a few minutes. our event will come in through this, and we can check. We have an inspect. We have a log. We have a log there. So the object, this line, has been logged here. Taiwo, all that, and then we add that to the list. That's why you can see it in the listing here. That is the point. So that is state that we are writing to states through the dispatcher. Remember, we said if you're writing, you have to go through the dispatcher. And then if you want to get all friends, which is happening here, we're also doing that. In the case for deletion, we're deleting by email. So I think we can just add another line here, console. So remember what is coming in from an action. We have the type, which in this case is delete friend, and we have the payload. So about to delete friend with a certain email will be the payload, because the payload is the email. So data.payload. So we can just check on this. Okay, I hope you've realized we've lost state. So this is a basic example. State has been lost. But yeah, let's look at this. So I'll create Taiwo once more with a certain email and a certain phone number. I'll add that friend. Then you want to delete so that you confirm our line comes in. So about to delete friend with email, taiwo@gmail.com. So it means it's coming to this block with a certain payload and doing the necessary by removing, then updating state, then breaking. Now for get friends, this is being called every time you get into that page, about to get friends. So about to get friends will just pop up here. Yeah, about to get friends is here. So our action is being triggered whenever you load this page. Now we've looked at the action, we've looked at the dispatcher, we've looked at the store. Now let's look at the view. What's happening in the view? So for instance, the creation, you just call the event dispatcher, then you pass in the create friend action, that is the type, and then you pass in the payload as this.friend. This friend is being bound in the HTML section. As you can see, these ng models, friend.name, friend.email, friend.phone number. We're doing all that. And then when you start saving, you pick this as it has been updated. And then you call the event dispatcher, call next on it, and then supply the action. So you call the dispatcher and you supply the action. Our action is create friend, and the payload is the friend object that is here. In terms of listing, so there are two things that you're doing. For listing, we are doing it on the home, on the app component.ts for the listing. So what we do is you subscribe to the store, get the friends from the states, and you're done. And whenever you're initializing, you also do event dispatcher, and then you pass in the action, get friends. For deletion, which is here, you call the event dispatcher, pass in an action to this method, delete friend. So the action is delete friend, and the payload is our email. In our case, was Taiwo. So that's how you're passing in, and these things are coming here as inputs because we are calling all these elements, or sorry, all these components are being called in the app. So this is what it means. This friends is the input to this guy, because you are loading the friends here. Yeah. So I think that gives some hint on what it takes to do state management in RxJS. It's just a simple example. We can do more complex stuff, but for demo's sake, I thought we'd just keep it simple. Yeah, and I think that's it. Any questions are welcome. I can take it back to Taiwo. So we are done. Thank you for listening. I hope that helps with state management using RxJS. Remember, there's something we never looked at. We said that there are two design patterns that you are looking at, the observer design pattern and the iterator design pattern. So maybe you can check out the iterator design pattern. Otherwise, I thank you very much. And yeah, back to you, Taiwo.
Okay, thank you very much, Brian. Thank you for the insightful presentation that you shared with us this afternoon. So, as he said, if anyone has a question, this is the time to ask. Is there any question? Okay. If there's none, I have a question for you, Mr. Brian.
Okay.
All right. So, can you give other, like just mention examples of applications that you've used RxJs to manage states in and the challenges you've encountered while using RxJS in them?
Yeah, that's a good question. One example is in an e-commerce thing, where you have orders and you have a cart. So there's a certain relationship between orders and cart. So you can imagine a scenario where you have two components that are calling. Okay, you have to make API calls every single time you get into a component, yet you're just calling the same thing. So an example is in terms of sharing data between two components. It's usually not very easy to achieve that in Angular, because then you'd have to call services to every time you get into a certain component. So what we did is we used RxJS to maintain the state of our application, so that if you move from this component to another, there was a parent-child relationship between the two. Instead of keeping on making API calls, which are very expensive, and remember that is breaking the rule of reactive applications, because you're making API calls every single time. We just have a common pool and maintain state in one guy as a singleton, and then you can read your data from that one source of truth. Yeah, so I think that is one example. In terms of challenges, I think this state management thing using RxJS brings in a certain complexity. It's not as straightforward as it looks, and so you have to get it right. And yeah, so in terms of implementation, you have to make sure your data is in sync. What the API is returning and what you have in your state, you have to make sure it's in sync, because if you update, you have to update your state. If you update any single element, so that is the complexity that comes in with using state management in RxJS. I don't know whether that answers your question.
Yes, it does. Thank you very much.